this case study, we are going to learn how to configure site-to-site VPN using GRE tunnels on Palo Alto Firewall. This is the case study we are going to work with. So in this particular case study we're going to learn about what? Site-to-site VPN with GRE tunnels on the Palo Alto Firewall. In this case, we have say one head office here, one branch office here for a company called as Mango. So this is Mango head office here. This one is what? Mango branch office. Mango head office and Mango branch office. This is one private network here. Thus also is another private network. We have used here private IP address scheme in the Mango head office. In the Mango branch office also, we are using what? Private IP address scheme. These two private networks would like to communicate with each other through the public network, internet. The head office and branch office are connected to each other through internet. So here you have say ISP router, this ISP network here, this is like say internet in the diagram. So the Mango head office, which is a private network, would like to communicate with the Mango branch office, which again is what? A private network through the public network, through internet. They would like to communicate with each other through what? Internet. So what is IP address scheme here we are using in the head office and branch office? We're using let's say 192.168.11.0, 192.168.12.0, and 192.168.13.0. So some systems are there in 192.11.0, 12.0, and then 13.0. So these are the network IDs we are using in what? Mango head office. And all of them are what? Private IP addresses. What about branch office? The branch office you're using these particular network IDs 192.168.21.0/24, 22.0/24, 23.0. Some systems are there in 192.168.21 network ID. Some systems are there in 192.168.22 network, and some more systems are there in 192.168.23.0 network ID. All these are what? Private IP addresses. So the systems in the head office, which are on a private network here, would like to communicate with systems in the branch office, which are also in what? Private network ID. And they want to communicate through public network. So what is the problem here? What's the problem in these particular systems trying to communicate with the systems in the branch office here? What is the problem? The problem is with what? Routing. On the ISP routers, routing is not defined for the private IP addresses. On the ISP public network, right? The ISP routers, they do not have route in the routing table for the private IP address. Why? Because private IP addresses are not unique. So they don't do routing for what? Private IP address. What is the range of the private IP addresses? Entire 10 network ID, 172.16.0.0 to 172.31.25.25, 192.168.0.0 to 192.168.25.25. All these networks, these IP addresses are reserved for private use. In other words, 10.0.0.0/8, 172.16.0.0/12, and 192.168.0.16 are reserved for what? Private use. What do you mean by saying they are private IP addresses? They're not unique in the world. Anybody can use these IP addresses. They're not unique. So routing is not defined on the internet routers for this particular private IP addresses. So the problem is ISP routers do not forward the packets with IP addresses. Friends, understand, no? So whenever any packet comes to ISP routers, when they open the first cover, open the second cover, see the third cover, they see the two IP address over. The two IP address is a private IP address. They can't forward the packet because they don't have route in the routing table for the private IP address, right? So that is a problem. That's why these systems cannot talk to those systems because they're using what? Private IP address. So now let us see as to how the lab setup is done now. If at all you see the Mango head office, here you say Mango HOSW1 and HOSW2. There are two switches in the network here. On Mango HOSW1, we have say what? We have three VLANs, VLAN 11, VLAN 12, and then VLAN 13. So this interface, so in the database of Mango HOSW1, we should have created like say VLAN 11, VLAN 12, and VLAN 13. And then we should have kept this interface Ethernet 0/0 in what? VLAN 11, 0/1 in what? VLAN 12, 0/2 in what? VLAN 13. And this particular interface here, Ethernet 3/0, should have been configured as what? A trunk link, right? This should be acting as what? Trunk link. And if you see here, 192.168.11.0/24, these systems are in what? VLAN 11. So the broadcast domain is 192.168.11.0 at the network layer and VLAN 11 at the data link layer, right? So these two are mapped to each other. Similarly, 192.168.12.0, VLAN 12, 192.168.13.0, VLAN 13, right? So the three VLANs configured on this particular Mango HOSW1, and this port is acting as what? Trunk port. So let us see this. I go to the lab setup here. I go to Mango HOSW1. On Mango HOSW1, I give the command show VLANs. When I give the command show VLAN, it shows that these VLANs are configured on this particular switch. Which particular VLANs are there here now? We have say VLAN 11, VLAN 12, and VLAN 13, right? So these VLANs are there in the database along with the VLAN, which is a default VLAN. Now in the system here, I give the command show. I also give the command here show interfaces, status. When you give the command show interface status, it shows that these particular ports are in this particular VLAN. So if you see here, if you see Ethernet 0/0, VLAN 11, 0/1, VLAN 12, 0/2 is in what? VLAN 13. And 3/0 is acting as what? Trunk link. This has been configured as what? Trunk link. If I give the command show interfaces trunk, it shows that this particular port is acting as what? Trunk. Trunking is on this particular port. Interfaces trunk, it shows that Ethernet 3/0 trunking is what? On. Status is trunking. And to add the tag, 802.1q protocol is being used. And these particular VLANs are tagged. VLAN 1, 11, 12, and 13. These VLANs will be tagged when the packets are leaving this interface at Ethernet 3/0 interface. Leaving the switch at 3/0 interface, right? As shown in the diagram here. Now, similarly, I go to Mango HOSW2. Let us see how this particular switch is configured now. Now, if I go to this particular switch here, the second switch, HOSW2, this particular port should be acting as what? Trunk port. Because this connection is between what? Switch 1 and switch 2. This should be acting as what? Trunk port. And then even though there's no VLAN port membership, these VLAN should be known on this particular switch. VLAN 11, 12, and 13 should have been configured on this particular switch. And then we configure SVL like VLAN 11, VLAN 12, VLAN 13. These are called as what? SVL, switch virtual interfaces for VLAN 11, VLAN 12, and VLAN 13. And IP address would have been assigned as 11.1, 12.1, 30. So inter-VLAN routing for all these VLANs is being done by whom? This particular switch, which is a layer 3 switch. So let us verify all these in this particular switch now. So now I go to Mango HOSW2. I go to Mango HOSW2. SW2, right? What do I do over there? There I give the command show VLANs. So these VLANs are configured on this particular switch, even though there's no VLAN port membership. VLAN 11, 12, and 13 should have been configured in the database of Mango HOSW2. They should be known in the database of this particular switch, right? Then I give the command show interfaces status. When you say interface status, it shows that this particular port here is acting as what? Ethernet 3/0 is acting as what now? Trunk port. This is acting as what? Trunk port. And then if I give the command show interfaces trunk, it shows that these particular tags via Ethernet 3/0, it will have the VLAN, this particular interface will be, the VLANs will be tagged at this particular interface, Ethernet 3/0. The trunking mode is on mode. And then here, the protocol which is used for adding the tag is 802.1q. And the status is what? Trunking. We can see all these options on Ethernet 3/0 interface. Now, if I give the command show IP interface brief, when I say show IP interface brief, these interfaces have been configured on this particular switch 2. Which interfaces are being configured now? On switch 2, we have configured interface VLAN 11, 12, and 13. These are called as what? SVI, switch virtual interfaces. And IP address has been assigned properly for these interfaces, right? And the line protocol also is made sure what? They are all up. So interface VLAN 11, 12, and 13 are configured on switch. If I give the command show interfaces VLAN 11, it shows that it is what? It is an SVI, show interface VLAN 11. It shows that it's a switch virtual interface with the IP address 192.168.11.1/24, right? Show interfaces VLAN 11. Like that, we also can give the command to see for VLAN 12 is also an SVI, switch virtual interface, and also VLAN 13, also one more switch virtual interface also is that. Then, so we have seen how these two switches are configured. So all the systems here, when they want to talk this particular system, the packet will go like this and then come back, right? So inter-VLAN routing is done by whom? This particular layer 3 switch. So if I give the command again on this particular layer 3 switch, I give the command show IP route. When I go here, I give the command show IP route. It shows that routes are there for these particular network IDs because all these are what? Directly connected. For 192.168.11.0, 12.0, and 13.0, send the packet via VLAN 11 interface, VLAN 12 interface, and VLAN 13 interface. So if everything is fine, if at all I go to HO system, Mango HO system here, I give the command show IP. Where am I? In the diagram, if you see, I am at this particular system here. From here, if I give the command ping 192.168.12.10 or 13.10, what should happen now? The packet has to go like this and then come back, right? So all the systems should all do talk to each other because the layer 3 switch here is doing something called as inter-VLAN routing. Let us see that. So now I give the command here. I say ping 192.168.12.10. I say enter. Everything is fine. I should get the reply, right? Similarly, I give the command ping 192.168.13.10 also I get the reply. So all the systems in different VLANs are able to communicate with each other because inter VLAN routing is being done by Mango HOSW2. Okay, let us see some more concepts on the Mango HOSW2 switch. When I say enter here, this particular port is configured as what? Router port. Ethernet 3/1 interface. No switch port command has been given here. By default is acting as what? Layer 2 port. By giving the command no switch port, this particular port has been configured as what? Layer 3 port. And then IP address has been assigned for this interface as 192.168.14.1/24. Let us see that. So now I go to HOSW2. I go to the lab setup here. I go to HOSW2. What do I do there? I do the command show run interface Ethernet 3/1. It shows that on this interface, you have given the command show run interface Ethernet 3/ shows that 3/1 has been configured as what? No switch port. No switch port. And then an IP address has been assigned like this, as shown in the diagram. So this particular port is acting as what? Router port. If I give the command show interfaces Ethernet 3/1 switch port characteristics, switch port features, it shows that switch port has been what? Disabled. So it is not acting as switch port. Show me the switch port features on Ethernet 3/1. It shows that it is not acting as switch port. It is acting as what? Layer 3 port. Means acting as what? Router port. So you could assign an IP address for this particular interface. So that's why when I give the command show IP interface brief, it shows that an IP address has been assigned for 3/1. An IP address has been assigned as what? 192.168.14.1. Right? It is not acting as what? A switch port. It's acting as what? A router port. We can also see all this when I give the command show interfaces status. Shows that this interface has been is acting as what? Routed. 3/1 is what? Router port. Routed means what? Acting as what? Layer 3 port, not layer 2 port. It is layer 2 port by default. I give the command no switch port and made it as what? Layer 3 port, so that I could assign IP address to this particular interface as shown in the diagram. Now if I give the command show IP route, this interface will now find a place in the routing table. So Ethernet 3/1 has found a place in the routing table, right? So because it has been configured as what? A layer 3 port, not as a layer 2 port. Again, if you see the diagram now, after making it as a layer 3 port, what did we do? And after assigning an IP address for this interface, what did you do? We added default rule saying any network anymore simply pass on the packet whom now 14.2. Who's 14.2? The Palo Alto Firewall here, right? So let us see that also now. When I go to HOSW2 here, I give the command show IP route. I can see this route in the routing table saying all zeros, all zeros, all zeros, all zeros. Send the packet go to 14.2. Who's 14.2? The Palo Alto Firewall. So what is happening here? So all the systems here, if they don't know the route, they send to their default gateway. The default will send to whom now? The layer 3 switch. They all send the packet to the layer 3 switch. Layer 3 switch doesn't have a route in the routing table. This will apply the default or sends the packet whom now? The firewall. Later we had a route on the firewall saying any network, any mask sent to ISP router, the packet goes, right? When all the systems want to talk to anybody else on the internet, the packet will go to the layer 3 switch, from layer 3 switch to the firewall, from firewall to ISP router. And all this happens by means of what? Default route. Any network NMAS. If you don't know the route, simply send the packet to the next hop router, right? So this is how the switches are configured on the head office network. Let's see it again now. If at all you see the diagram here, this particular switch is acting as what? Layer 2 switch. And we created VLANs and VLAN port membership here. And this is called as what? Trunk link. Trunk link. This is acting as what? Layer 3 switch, doing inter-VLAN routing for all the systems in different VLANs here. And the default route is that it's saying any net anymore, simply pass on the packet to the firewall. So this is what he configured in this particular head office. Similarly, let us go to the branch office and verify here. So if I go to the branch office again, on this particular BOSW2, we configured what? We configured VLANs, VLAN 21, 22, and 23. And these ports are, port membership also has been created on this particular switch here. So let us see, give the commands on the Mango SW2 now. And then this particular port should be acting as what? Trunk port, right? So let us see all this on BOSW2. So I go to the lab setup here. I go to BOSW2. BOSW2. There I give the command BO1SW2. I give the command show VLANs. So these VLANs are configured on this particular switch. Which VLANs are there now? VLAN. These particular VLANs are configured on this particular switch here. Which particular VLANs are configured here? VLAN 21, 22, 23. These are configured, right? Again, if I go here, I give the command show interface status. Show interfaces status. It shows that these interfaces are port membership has been configured. Ethernet 0/0 in what? VLAN 21, 0/1 VLAN 22, 0/3 VLAN 23, and 0/3/ is acting as what? A trunk link, trunk port. Is acting as what? Trunk port, as shown in the diagram. If at all I give the command show interfaces trunk, it shows that this particular port is acting as what? Trunk port. 3/ is acting as what? Trunking on mode, right? And the protocol used for trunking is what? 802.1q protocol. And this particular VLANs will be tagged when the packets are leaving via Ethernet 3/0 interface. So all this has been configured on the Mango BO1 SW2. Similarly, now let us go to the BOSW1. I give the command show interfaces trunk. It shows that this called interface Ethernet 3/0 is acting as what? Trunk port. Ethernet 3/0 mode is what? On. .1q trunking, and all these particular VLANs will be tagged while sending via this Ethernet 3/0 interface. It is acting as a trunk port. I give the command show IP interface brief. It shows that these interfaces like VLAN 21 interface, VLAN 22, VLAN 23 interface have been configured with 21.1, 22.1, 23.1 IP address, and the line protocol is what? Up. Line protocol is what? Up. I give the command show IP route. When you say show IP route, this is acting as what? In the routing table, these routes are the routing table, right? For 191.21.0 via VLAN 21, 22.0 via VLAN 22, 23.0 via VLAN 23, right? And if I give the command show run interface Ethernet 3/1, it shows that it is configured as what? A router port by giving the command no switch port command, no switch port. So this interface here is acting as what? Router port. It has been given IP address so and so IP address as shown in the diagram. And once we do that, we also give a route. When I give the command show IP route, a default route is added. See the diagram now? Once we do all this on the BO1 SW1, this has been configured as a router port, and a default route is added saying any net minima simply pass on the packet to the Palo Alto firewall, right? When I say show IP route, shows that the default route shows all zeros send via whom now 24. Who's 24.2? The Mango BO1 firewall, branch of his firewall. So like that, we configured the switches in the head office and also the branch office. To summarize, when all the systems, if they don't know the route, they all send the packet to the layer 3 switch here. It doesn't know route, it will forward the packet to the Palo Alto firewall. Later we configure a default route on the router saying if you don't know the route, you pass on the packet ISP router. So all the packets will go towards ISP router. If at all the packets, the route is not done in the routing. Same thing you have done on the branch office also. So we have seen how the head office network is configured here. We also have seen as how the branch office network also has been configured. Now we need to see now how to call the firewalls are configured. How the head office firewall and branch office firewall are configured. Let us see this. To the Mango HO firewall here, head office firewall, I go to network. There I go to virtual route. I see one virtual route already configured as what? Mango HO firewall VR1. So this virtual router has already been configured as shown in the diagram. Similarly, we should configure two zones like this, internal zone and external zone, right? Again, if we go to like say zones here, if we go to zones, you see that these two zones are already configured. One zone by name internal, another zone by name external. Both of them are what? Layer 3 in nature. So these two zones are already configured as shown in the diagram. Again, we also need to Ethernet 1/ and 1/ with proper what? IP address and keep them in proper zones and all. Let us see that. If I go to the lab setup here, if I interfaces, I can see that Ethernet 1/1 interface as we configured as what? Layer 3 interface and SN with IP address, also assigned to router, assigned to proper security zone. All this has already been configured. Similarly, Ethernet 1/2 defined as what? Layer 3 interface, assigned with IP address, assigned to the router, assigned to what? The security zone called as external. So this has already been configured on this particular head office firewall. What about routes? See now, on the head office firewall here, for 11.0 area, one route should have been saying that why Ethernet 1/1 sent to whom now? So and so IP address. For this event, for all, I should add a route on the routing table of this particular firewall. We should add a route in the routing table of the router saying for 11.0, pass on to whom? Next hop router, who's that? This is called layer 3 switch, right? And what's the IP address? So the 192.168.14.1. So let us see whether it has been configured or not. Now I go to the lab setup here. I go to virtual routers. There if I go to Mango firewall VR, when I click on it, there if I go to static routes, I see one static route already configured saying for 192.168.11.0/24, send the packet to 14.1 via Ethernet 1/1 interface. Via Ethernet 1/1 interface, send the packet so and so next hop address. For so and so network and so and so mask, send via so and so interface to the next hop address 14.1. Right? This route has already been configured on the HO firewall VR1. Similarly, if you see that diagram here again, for 190 to 168 dot, this route has already been configured. What about this 12.0? All send the packet whom now? By the same interface only. The next hop address as what? 14.1. Let us see in the diagram here. Lab setup. If you go, you see that for 192.12.0/24, send the packet by Ethernet 1/1 interface via to the next hop address, next hop IP address 190 to 168.14, which is a layer 3 switch in the diagram. So this route was added in the routing table. Similarly, for 13.0, send the packet again via same interface to whom? 14.1. If you see the diagram here, this route also has already been configured saying for 190 to 113.0/24, send the packet via Ethernet 1/1 interface to the next hop address 190 to 168.14.1. So these static routes have already been added in the routing table. Similarly, if you see the diagram, so after adding this particular static route, one more route. This is what? This is a public IP address. So we bought a public IP address from the service provider. Which particular public IP I bought here now? 20.0.0.1. This 20.1 is a public IP address bought from the service provider. We assign it to this particular interface. Once we assign the IP address here, we add what? A default route saying any network, any mask, all zeros, pass on the packet to whom? 20.0.2, right? Once we buy a public IP, we assign to this interface at a default route saying any network, any mask, simply pass on the packet to ISP router, right? Let us see this route also got added or not. Again, if you see the diagram here, it shows there's a default route saying any network, any mask, send the packet to 20.2 via interface Ethernet 1/2. Who is Ethernet 1/2 interface? The interface connecting to the ISP router, right? So these routes are already added in the routing table of the firewall 1 VR1 router, right? Now, if you see let's verify the routing table of HO firewall VR1. Firewall VR1 will have a routing table now. Which routes will be there? Route will be because this address has been assigned to this interface. A route will be there saying for 190 to 1.14.0, send via whom now? Ethernet 1/1 is directly connected, right? Because one more address is assigned, it also will have route saying what? For 20 network ID, send via Ethernet 1/2 interface. And then for this, we added a route saying next hop address is what? 14.1. So one route will be there saying for 192.111.0, send the packet via whom now? 14.1. We also had a route saying for 12.0, send the packet whom? 14.1. So one more study route will be there saying for 12.0, send the packet whom? 14.1. For this also we added route saying the next hop address is so and so. Route will be added saying that for 190 to 1.13.0, send via whom now? 14.1, right? And then because we added a default route pointing like this, 20.2, a default route will be there saying any network anymore, simply pass on to whom now? 20. Right? So let us verify the routes in the routing table of HO firewall VR1. How do I do that? I go to activities now. I go to the HO firewall. I go to HO firewall. Where am I? I give the username admin and I give the password as what? Capital P at the rate of SSW0 already. I log on to the firewall. There I give the command show routing route. I give the command show routing route. When I give the command show routing route, you show these routes in the routing table. Let us see now. First of all, let us see the directly connected network IDs. So route should be there for this and this, right? So if I see the lab here, it shows that for 192.168.14.0 is what? A connected route sent by Ethernet 1/1. You are the gateway for your own area. One more route is they saying that for 20.0/8 also, yourself can send the packet. Source is what? Connected by Ethernet 1/2. So these two routes are there in the routing table because these two are what? Directly connected. And what about the static routes? Routes should be there for 11.0, 12.0, and 13.0. Let us see this. If I see the lab setup, it says that for 11.0, 12.0, and 13.0, for 11.0, 12, and 13 network ID, send the packet by whom now? 14.0.0.1. Sorry, 14.1, 190.14.1. And all these are what? Static routes via Ethernet 1/1 interface, right? And then we added a default route here. If you see the diagram, default route says what? Send the packet home 20.2. So a default route also is there in the routing table saying when the packets are going for any network, any mask, if you don't know the route, send the packet home 20.0.0.2. This is what? Static route via Ethernet 1/2 interface. So like that, routes are added in the routing table because of our configuration on HO firewall VR1. We are seen as to how the routing table of HO firewall VR1. Let us also see, verify the configuration on the branch office firewall. If you go to the branch office firewall here, again this VR1 should have been created. This zone should have been created internal and external. IP address should have been assigned to this particular interfaces, right? Let us see all that now. So I go to the branch office firewall. I go to branch office firewall. I go to network. There I see one virtual router configured as what? BO firewall VR1. Then if I go to the security zones, I see two zones created here. Internal zone, external zone, both are what? Layer 3 in nature. And then I go to interfaces, I can see that these interfaces have been configured with Ethernet 1/1, layer 3 in nature, IP address, VR1, internal zone, and Ethernet 1/2, again layer 3 in nature, IP address, VR1, external security zone. So like that, the Ethernet 1/1 and 1/2 are also configured on the BO firewall, branch office firewall. Now, what about the static routes? For 21.0, send the packet to whom? The 24.1 via Ethernet 1/1 interface. Let us see this. So now if I go here, I go to the virtual router called as BO1 firewall VR1. There I go to static routes. There I see a route saying for 192.168.21.0, send the packet via Ethernet 1/1 to the next hop address 24. Who's 24.1? Mango BO1 switch 1 as shown in the diagram. Similarly, if you go to the diagram again, one more route should be there saying for 22.0, send the packet same interface to whom now? 24.1. If you see the diagram again here, the lab setup here, it shows for 22.0, 22.0/24, send the packet to 24.1 via Ethernet 1/1 interface, right? Similarly, again, if you go here to the diagram, So this route is added here. Again for 23.0, send the packet same interface to whom now? 24.1. Again, if you see the routing table, it shows that for 23.0/24, send by Ethernet 1/1 interface to the next hop address 24.1, right? So like that, these routes are there in the routing table. Again, if you see the diagram here, so this route, these three routes are there, sent to what? The BO1, SW1. And this address is what? A public IP address. So we wanted our systems to talk to internet. So we buy one public IP address 40.2 from the service provider. We assign it to this interface Ethernet 1/2. And then we add a default route saying any network, any mask. Any network, any mask, send the packet whom now 40.0.0.1, right? The default would be added like this. So that's what we added here. If you see the lab setup here, it shows that all zeros, all zeros, all zeros, all zeros, right? All zeros, all zeros. Send the packet home now 40.1 via Ethernet 1/2 interface. So like that, these four static routes are added in the routing table of the virtual router running on the branch office firewall. This has already been configured. So now if we go to the diagram, let us verify the routing table of branch office firewall. Branch for firewall, VR1 router on branch office firewall. So routing table will be there like this. Route will be there for this Palo network because what is directly connected. Route will be there for 40 network because what? Directly connected. For this we added route like this, right? Send to whom? 24.1. So one static route will be there saying for 190 to 168.21.0, send the packet whom? 24.1. Again, we added a static route like this. So one more route should be there in the routing table saying for 192.22.0, send the packet by whom now? 24.1. Again, we added a route for 23, send the packet like this. So what happens now? One more route will be there saying for 23.0/24, send the packet whom now? Like this, right? And then a default route pointing to whom? 40.1. So a default would also be there saying that so and so net so send the whom now 40.1. Let us verify all these on branch office firewall. Again, I go to activities. I go here to the branch office firewall, BO firewall. I say admin is the username. I get the password as capital P at the rate of SSW0RD. I log in. There I give the command show routing route. I say show routing route. When I give the command show routing route on branch office firewall, it shows a routing table like this. Which routes are there in the routing table now? Let us see. Let us first of all see the connected routes. These two are what? Connected routes, right? So here we can see in the case study, route is there for 24.0 because it is what? Directly connected. Route is there for 40 network ID because it is what? Directly connected. And route is there for these areas. Route is there for 21.0, 22.0, 23.0, right? Because all these are also there. So route is also there for these areas. 21.0, 22, 23. Send the packet via whom now? 24.1. These are also what? Static routes, right? And one more route should be there saying any network, any mask, send the packet whom now? 40.1. Default route should be there. We also see a default route in the routing table. Any net, any mask, send the packet whom now? 40.1. What static routes? So these routes are there in the routing table of branch office firewall, BO1 firewall. We have seen the routing table of HO firewall and also branch office firewall. Now let us see the routing table of the ISP routers. If I got ISP R1 router, routes will be there for 20 network ID and 30 network ID because these two are what? Directly connected. And we would added one route saying that for 40 network ID, pass on the packet whom now? 30.2. 40 is a public network. 40 is what? A public network. So route should be there saying what? For 40, send the packet to 30.2. I added the route here statically here. We added what? Static route. Similarly, route should be there in the routing table of ISP R2. Route should be there for 30.0.0.0 because what? Directly connected. Route should also be there for 40 network ID because it is what? Directly connected. And one more route should be there for 20 area for 20.0.0.0. Pass on the packet whom now? 30.0.0.1. Right? These routes should be there, right? Let us verify that now. So I go to the case diagram. I go to ISP R1 router. There I give the command show IP route. It has routes in the routing only for 20, 30, 40 network IDs only. If you see the diagram here, it has routes for 20 network, 30 and 40 network ID only because 20 network, 30 and 40 are what? Public IP addresses in the topology diagram. The ISP doesn't know route for 192, 160, 11, 12, 13, 21, 20 all because these are what? Private IP addresses. For private IP addresses, ISP routers don't have route in the routing table, right? Similarly, again, if I go to ISP R2 router, there again I give the command show IP route. When you say show IP route, routes are there only for 20, 30, 40 network IDs only. See the diagram here, routes are there only for 20 network, 30 network and 40 network only. No routes are the routing table for the private IP addresses. So ISP routers have routing table only for the public network IDs only. We have two ISP routers in our topology diagram. Only three public network IDs are there, 20, 30, 40. So both the routers know routes for 20, 30 and 40 network IDs. They don't know route in the routing table for 192 to 168.11, 12, 13 and also 21, 20, 20 because these are what? Private IP addresses. Now, so we verified the routing tables of the head office firewall, branch office firewall, and also ISP routers, right? Now, let us continue now.